Good day and welcome to today's webinar, Revolutionize and Transform Your Application Delivery Lifecycle with HP Service Virtualization. This webinar is brought to you by HP. My name is Todd DeCapua, and I will be hosting this call today. And as you can see, I've been a champion for Vivid, a number of different capacities. Today I am leading as a champion the Performance Engineering SIG, also as a senior manager with HP Software, and also a chief technology evangelist. Today's speakers, we have two of them. Kim Yo, who is the worldwide senior product marketing manager for HP Service Virtualization, and she is also joined by Mirik Novotny, the senior product manager for HP Service Virtualization. Housekeeping items: this is a live session. It is being recorded. All recordings will be available to Vivid members. We are going to be having a session Q&A, so please type any questions that you have in the questions pane. And if we go to the next slide, this is what that will look like. So in your question pane, you should see an area that says questions and chat, and then where you see this big arrow with questions next to it, and it says type your questions here. Simply type in whatever question you have, click send, and we will hopefully get to all of them. If we do not get to all of them, the Q&A will be on the Vivid website with all of the answers to the questions that we were not able to get to. We're going to start with two quick polls, so keep your eyes on your screen and please respond to poll number 1. So have you heard of or have you used Service Virtualization before this event? There's 5 choices that you have. The first one being no, I am new to Service Virtualization technology. The second, no, I use homegrown stubs or mocks. Yes, I've heard of Service Virtualization, but I have not and do not use it. Fourth, yes, I've heard of Service Virtualization. We're currently evaluating. And lastly, yes, I've heard of Service Virtualization, currently in use, and are planning to continue to use Service Virtualization. So please select one of those 5 items in our quick poll, and we're just going to wait for a few more moments here to see what the results look like. I can see everybody's votes are coming in quickly. Excellent. Let's go ahead and close this poll and see what the results look like. So of those who responded, it looks like no, I'm new to Service Virtualization technology actually accounts for 22% of the respondents, and then ironically, it's an equal split of 26% across the last 3 of yes, I've heard of Service Virtualization. So 26% have not but do not use, 26% currently evaluating, and the last 26% currently in use or plan. So let's move to the second quick poll, and again, this will be the last one. Appreciate your quick input on these. What is look into Service Virtualization technology? And please check all answers that apply for you. The first being continuous integration and delivery requirements. Second is agile projects and parallel work streams. Third, aggressive project timelines and time to market. Fourth, enterprise level performance center of excellence initiatives. And lastly, costly development and test environments. So again, if you could please select all that apply to you, and we'll just wait a few more moments here to make sure everyone can get the answers in. Just one more minute here. We're seeing them come in. Wow, look at that. So we were actually able to get almost everybody participating in this poll, and it looks to be a fairly equal spread across all of these, with the exception of an enterprise level performance center of excellence initiative. So again, if I were to look very quickly at these in order, costly development and test environment would come out first. Then tied for second is continuous integration and delivery requirements and aggressive project timelines and time to market. Then followed by agile projects and parallel work streams. And finally, the enterprise level performance center of excellent initiatives. So with that, I'm going to go ahead and turn over this webinar, Revolutionize and Transform Your App Delivery Lifecycle with Service Virtualization from HP, to Kim Yo. And again, Kim is the Senior Product Marketing Manager for HP Service Virtualization. Over to you, Kim.
Hi, everyone. A very good morning, good evening to all of you, and thank you very much, Todd, for the warm welcome to us. And let me just go straight into this presentation today because I know we are running a little bit late in starting this. Our apology. So let's just keep going here. The topic today is on revolutionizing and transforming your application delivery lifecycle with HP Service Virtualization. So here, today, we are seeing the rise in modern applications and trends towards mobile, DevOps, cloud service integration, and Agile. All these help bring flexibility to businesses in terms of getting them to the market faster, increase their brand value, increase their customer loyalty, as well as at the same time reduce costs and deliver amazing user experiences. A classic case here, which most of you will be familiar with. I'm sure everyone have heard of the name of Starbucks. And in recent years, we have seen Starbucks extending their traditional brick-and-mortar business model to now enable better user experience through mobile payment, and even to extent of pre-advanced ordering and payment before they pick up their drinks. And lately, as some of you may have known, of course, it's not applied to all around the world. It's just in certain regions of the market. They have offered to team up with companies such as Postmates to provide order delivery. And they are not alone. There are other businesses such as Walgreens, your neighborhood pharmacy retail, restaurant chains such as Chipotle. They are all jumping onto the bandwagon, and they are also trying to offer things such as pre-order delivery with partnership with Postmates. So all these things are really changing the whole landscape of how businesses are serving their customers, and these all do have an effect on all these modern applications and trends. And just yesterday on the news, Chipotle's earnings release was, it was known that the sales was down tremendously, I guess. And they recognized that 2/3 of their customers are buying and dining outside of their stores. So one of the things that they plan to do is to increase more resources and making sure that they are optimizing their mobile order platform. And again, this is all showing us that these are all here to stay, the trends. And what it does is that it's going to bring more challenges and constraints to the software development lifecycle. So here is showing that these are the 3 quality trifectas that most businesses are striving towards: velocity, quality, user experience. On the far left, the need for velocity has led to a 30 times increase in app releases, according to the latest 2013 study. On the quality end, the bar has also risen. These consumers have grown up with the expectation that their experiences are mobile, it's always on, 24/7, and it can be accessed anytime, anywhere through multiple devices and platforms. Hence, we are seeing that customer tolerance are very low. 50% of them will delete a mobile app if they encounter a bug. Because of all this need to meet quality trifecta, we are seeing a proliferation of disparate tools being used and a rise in composite apps to meet the expectations. So how are businesses managing composite applications? And this is where I'd like to share with you a story. This is a true story from a recent conversation I had with one of our customers. I can't say the name right now, but one of their case studies will be coming up shortly. They are very well known and huge in the retail gaming entertainment industry. Like most organizations, they are heavily invested in composite or service-based apps. They have huge number of applications, components with multi-channels. These component systems are all over the place, homegrown, on the cloud, and even included some third-party vendors as well. Each of these have got their own SLAs and performance dependencies, and it's crucial for his team, the central QA, to have all these pieces integrated, ready, and available with data aligned for testing. When their customers go online to purchase their product, as you can see here in this process flow, this online purchase request will have to interface with other dependent components in the backend, such as inventory system, product part number check, customer profile, as well as credit check. To add to the complexity, some of these applications, they have to rely upon their third-party vendors who run the program for them. In the case of this customer, one of their key components is the customer rewards program. And I'm going to get to that in a minute. In this retail business environment, which they are in, Q4 is a huge time period for them with Thanksgiving and Christmas seasons. Just imagine having enormous high volume of customers trying to get online to pre-order a game, especially the new releases which they've been waiting for months to have, whether this is going to be a gift for their kids or for themselves. So just imagine what this does to the order processing load. And the ability to perform pre-production performance testing is really super critical for his team here in these situations. So in their case, as I alluded to earlier on, the customer rewards program is one key critical application component, and it's a huge component that touches on all other components of their apps and system. They need quick access to this, which unfortunately they do not have, as the app is run by a third-party vendor, and they need to rely upon the third-party schedule to do their work. In his own words, it has been very frustrating for his team and himself. The third-party vendor who handles their customer rewards program was very slow to provide customer profile, sometimes taking more than a week, and they stumble to get the information they need. In other cases, they also face other third-party apps that either do not have production environment, or they can't access the production environment too much, or they will get blacklisted. Does this ring a bell? Am I seeing some heads nodding? So what are they faced with? Constraint. All kinds of constraint. Constraint in delayed schedules, limitation in accessing some of these systems and apps, reduced testing, development slowdowns. So like most organizations, they're facing a lot of constraints. In a recent work study, 2015 Service Virtualization report, it showed that more than 80% of QA work and development work are delayed while waiting. And the notion is that you can't do anything until you have everything, and the fact is you will never have everything. So this is where service virtualization comes in. Service virtualization helps to compress the whole software development lifecycle, and it allows DevTest teams to be able to shift left some of this work up front and have the savings in time and cost as well. In the same report that I was telling you about, the interesting data finding is that before service virtualization, it takes them an average of 32 days of waiting time. And upon using service virtualization, that time has been cut down tremendously to just 1 hour wait time. So for this customer, which I was telling you about, it really did show them a huge ROI. After using service virtualization, they were able to cut off 6 to 8 weeks of wait time on one of the main components they depend upon. And it took him less than 5 minutes to get the testing up and running. And you're going to see that later when Marek demo to you the HP Service Virtualization, how easy it is to set up and use. And here on the slide, you will see the rest of the ROI findings from the same work report. The general trend here, as you can see, is that service virtualization reduced release cycle, test cycle, and defect production time by up to 50%, while the number of defects down by 40%, and businesses are seeing twofold increase in test coverage and test execution rate. All these details, as well as the report itself, we're going to make it available again, the link at the end of this session. You can also see the link here at the bottom of the slide. And with this, I'm going to turn over to Marek, who will walk you through what service virtualization is and how HP Service Virtualization works.
Okay, hello
Marek?
everyone. Yeah, can you hear me?
Yes?
Yeah, okay. So do you see my screen?
Not yet.
Yes, I see the solution. Looks good.
Okay, perfect. So let me walk you through the solution to those problems that Kim just highlighted. So if we look outside of the industry, of IT industry, we can find parallels to the problems that certain businesses or certain technologies have the same constraints. How do they come up with the production version of the product? So if you come to the airlines industry, they do quite a lot of simulation. They simulate and train pilots on a virtual environment. They simulate the planes, various systems before they actually the planes are taking off to the air. If you look on the NASA before they go to the Mars or they go to the moon or other missions outside, they do quite extensive testing and try to come up with various scenarios for those systems and devices to answer the questions: what happens if this rock hits the wheel, and what happens if the camera is not responding in the right time, and so on. So in our IT industry, obviously, we have a specific processes about for the application delivery. Developers are the first that are touching the application requirements. They translate them into the code, and they should have the ability to start leveraging the technology, simulate and answer the questions: what happens to my code under certain conditions? Obviously, we do it from a testing point of view. When we start to do a manual testing, we are answering exactly those questions. When we start doing the automation testing, we do even more coverage in a shortened period of time. But it's not enough. There are some constraints to accessibility of the systems. So in a history of distributed computing, developers basically come up with a solution, and those solutions are called stub mocks and other mocking solutions to those APIs and systems. But there is a trouble with the stubs. Stubs take time to develop. Stubs consume developer resources. They have a restricted functionality. They have very difficult maintenance. And it's basically, while it is doing the job of communicating to the original system and trying to do sort of simulation, usually it's not self-service and it doesn't scale. What we see on our customers that are using the stubs, it's usually when the performance testing hits the cycle, those stubs are crashing, and they can't answer those what if scenarios. So that's why the service virtualization come up and starts to be a key answer to those questions. How can we improve our KPIs? How can we improve the process? How can we eliminate those constraints? So if we dive one level below to application architecture, because that's where we are seeing those troubles, we see that we have multiple layers. We have a UI, we have middle layers that is usually being developed, and then there's sort of connections to third-party services or to various legacy systems. There's a lot of technologies that is used in today's enterprise organizations. So what service virtualization is doing is basically introducing the layer between the application that we develop and test and those systems that have a restricted access. Those mainframes and SAP systems and payment services delivered by third party are now being simulated by service virtualization layer. We simulate those services from various point of view. One is we allow users to specify the connectivity configurations. So you basically specify what is the endpoint, what is the technology, and we, by this, virtualize the system. Then, obviously, the next step is to create the data representation of the communication. So we allow you to represent the simulation model in that. And if you go to the scalability scenarios, we also allow you to simulate the performance. The easiest way to alter the virtualized services is by learning. If you have an existing system that is just not available in the right time or it's not scaling, you can just press the button and learn the transactions, and it is stored in a virtual service, and then you basically hit the simulate and it's simulated. But the world is not that easy all the time, so we offer also the different ways how to alter the service, alter the services, and I'll show you in a demo how to actually read more from the developer point of view. So what are the cases of service virtualization? So coming back to the complexity of the architecture, there is many, many layers. And we, from HP point of view, we try to offer the solutions for simplification of those complex testing environments. The outcome of those simplifications is obviously reducing the cost, speeding up the process, having quicker turnarounds of the testing cycles, and having overall development process. So what we typically see is that we have the certain application under test. We have a network infrastructure. We have users that are accessing the UI over the various UI technologies, and then you have on the back end you have systems that you need to provision, you have to maintain, you have to provision the licenses, you have to have the right people, and so on. And you have to align for the testing, you have to align the data along the way. So what users are entering on the left side must be presented on the right side for the transaction to go smoothly back and forth. So there's a lot of challenges. So we are actually coming with the answers. So the first answer that we have is the service virtualization. So that's what we are talking today about. We allow you to virtualize those communication points and simplify the communication to the backend system by simulating. We also simplify the network. We have a component called network virtualization. So it is tightly integrated to our portfolio. And it allows you to fiddle with the network parameters, model and simulate what happens on a network if the packets are lost, and answer the questions, is my application resilient enough? And obviously, we also allow you to virtualize the users, lots of users, hundreds and thousands of the users. We have solutions like Load Runner Performance Center and Storm Runner Load that allow you to do very easy from the user point of view. It is all integrated into one solution that is allowing you to simplify the test environment and answer those questions for the application under test in much quicker way. So from the developer point of view, you might ask, so what I do when I don't have actually everything in place, when majority of the systems is under construction. So we have a solution even for that. So you don't have to wait for the system to be available. You get the access to the documentation of this system. You understand interface, or you can start designing, co-designing the interface, and you basically create it in virtual service, and you can start simulating the transactions. You can enhance the model on the way. As you are creating more and more transactions in your UI, you can always come back into the service virtualization and keep adding those transactions, for example, from the log file and so on. So it helps us to achieve the faster release cycle and faster development mainly from the developer point of view, because they don't have to wait anymore. And another very difficult case for our customers is, okay, so when I have the application ready, I need to make sure it scales for a Black Friday. It has the access from various UI portions. How do I deal with it? So again, so you need to have the virtual users. So you are starting to use the automation tools for that. That one is quite easy because it's accessible, and you just issue the large scale of the testing scenarios. What is more difficult is how do you deal with the backend? How do I access the mainframe for my performance testing? For every transaction that I access in a mainframe, I have to pay for. CRM might not be available for performance testing at all because it's in production all the time. Third-party payment is costly, because if you need to run this performance testing extensively for 6 days, as our customers, some of them do, it's a huge cost and a huge burden if they allow you to do performance testing in the first place. So obviously, what you do, you use the service virtualization, and you create a virtualized mirror of those communications in a very easy way. But you also want to have the various networks. You want to have the users accessing over the cellular network. You have some users that are using it in over the Wi-Fi in certain locations like cafeterias or offices. And then obviously you might have VPN access for back office users to the same application. So network virtualization allows you to model those conditions on a client side. It can be modeled on the backend if it is going to the separate data center as well. And what is the beauty of our solution? That it is all integrated. So in one place, you have the ability to set up the conditions for the users, network, and the virtual services, various profiles. And then as you execute the test, you will see that we are able to collect the information and get the insight what's happening in the virtualization layer, and then do the result correlation and answers. Okay, so we need to test this, or we need to fix this is a major issue. So what we see at the customers, that basically by using this, they increase test execution and test coverage. Test coverage is important metrics because it is directly influencing the user experience, number of defects, number of production incidents in a production. So let's actually see this in action. So I'll switch into it's a live demo of the service virtualization. So what I'll be doing is combining those two scenarios of the developer and a performance tester. So as a developer, I'm trying to develop the application that communicates with the FedEx, and my application is actually having the trouble to access the FedEx system. If I execute the code, I don't have any connection, and usually I get no connection available or some sort of the connection. So I can't go actually forward. I can't execute my development. I don't know if my code works. So what I can do, instead of waiting, I can actually use the service virtualization product. So this is a designer private where we start authoring the services. And I'll select the way to create the service by designing the virtual service. I have two options. I either start selecting the technology that I need to have, or I already know that there is a technical construct like COBOL copybook, schema, or WSDL, or REST descriptions, and so on. So I can just point to it, and the service virtualization parses all the information and creates the skeleton of the service. So I just need to give it some meaningful name, save, virtualize, and now we are processing all of the metadata that is in this technical construct and creating the virtual service that is ready for the testing. So here you go. We've created the virtual service. The virtual service contains the physical endpoint, so I can actually point into this and already get the connection. We have the data. In the data, we have a pre-generated transactions for every operation. So every operation has the data that is being sent back and forth. And we have also some performance model, but that's not important from development point of view right now. So what I can do is basically click simulation. I can actually turn on the message logging as well. So let me actually turn the message logging and come back to my code. And in my code, I can execute, again, the same scenario. And in this case, I don't see the error about the connection. I see that the connection already went in. The trouble for me is that the coverage is not what I expect. I see some generated data, and while I do the communication, it's not what I expect. I need to test for the specific labels and data and so on. So what I can do in a very easy way, just see what has been sent in a log file in a communication. So I see the request and the response, and I can also go into my data model and start enhancing the model. I can import the request and add the response, or I can simply create a new rule. We have a rule-based engine. And this rule-based engine allows you to actually create the logic by setting up what is the request, what is the associated response, and do some parameterization, do it dynamic, and so on. So let me just use typical way what the developers are doing. They usually have external samples from the technical interface, and I will just do simple way of importing those samples into my model. I need to change the state from simulation into the edit, and I just go and select all the requests that I have, and also select all the responses that I have as a sample. The code is smart enough to parse all of those messages and actually do the association, and then from this heap of the messages, import the data into right places into the virtualization model. So if I click on it, it processes the message and gives it into the model. So what we see here is that we have some more data. We can have a different view, and I know that in my data, usually the time is causing the trouble. So I may start setting up the conditions. So for example, for the time, I don't want to use this condition for the simulation. I can also specify some specific conditions on a return. So I can make it dynamic. I can copy from the request to response. I can generate some random data and responses. I can have some dynamic data that are working with the time and day that is relative to the specific milestone or specific request or existing time that is on the computer. Or I can create my own functions that are actually reacting to the request and response. So there's much more complex ways how to describe the model. But for me, it's good enough. So I just save the model, and I go back into my service and switch it back into the simulation. So what I did, I improved the coverage of my data. So I can go back into my application because I have represented those scenarios and execute again the test. Now I'm getting again the different result, and the result is exactly what I wanted. I wanted to have some processing of the label, so we were able to process the data for the label, so I can move on and start doing another scenario. I can import more data. So what I was able to do is, instead of wait for the FedEx to be available for me, for the developers to give me right access and the endpoint, I can right away start doing my code. So I eliminated the wait time whatsoever. So now comes the performance testing time. So what I need to do is I need to actually specify how this application behaves under the load when there is not only one transaction, but where is the more transactions. So for that, we have the performance part of the virtual service. So what I'll do is I'll actually create a slow performance model as a new one, and I can go into it. And for every operations, we are able to simulate various parameters like response time, what is the throughput, transaction limit. We can even do complex scenario modeling for batch processing simulation, which is used for our customers to mimic the behavior of the asynchronous communications, where you send millions of the transactions in, and then you chunk it and you process it in batches and perform and simulate it back. But for a simple scenario, let's say we want to actually work on a tuning and testing of the process shipment method. So in this case, I can, in a very graphical way, I can specify so that my response time is actually 1 second. And on a horizontal line, you see the threshold. So I'm not able to right now simulate thousands of the transactions, but if I would be able to do that, we can change the characteristics of the model and say that it's slowing down and then it's breaking and so on. So quite a flexible way to actually simulate how the application behaves under the load. But for our case, just to demonstrate the functionality and how easy it is to use, let's say this is our performance model. So another aspect is important to understand that this designer environment is actually just for the design. It's not scaling. So what we have is also another part of the infrastructure, that is the Service Virtualization Server. Service Virtualization Server is actually a standalone component. It has a web-based UI. In this web-based UI, you are able to see what kind of the applications and environments you have provisioned. It is also integrated for easy access, so I can very easily just select endpoint of such a server and just say deploy, finish, and it is actually, instead of using the embedded limited version of the simulation engine that is used mainly for the design purposes, I'll now have it deployed into this Service Virtualization Server. So it will actually pick up here in the server among the services. So we see that FedEx is now deployed. So now my role is I'm practitioner of performance testing. So I'm using LoadRunner. That's my tool of choice. And in the LoadRunner, we have the integration with the Service Virtualization. What we allow users to do is, in a very easy way, to start configuring those conditions that needs to be provisioned for before the load test is executed. So I go to the server and import the specific characteristics of the FedEx component that I want to have provisioned. I say that I want to have the specific data model, and I use the default performance model, and I save the setup. So this way, I ensure that every time the performance test is executed, this environment with the specific data and specific performance will be provisioned for my test. So now we come to the execution time, and we basically execute this scenario in LoadRunner. We have a prepared scenario script, and we can, while it is picking up the loads, we can come back to our virtual service. So what we see here immediately, that this virtual service is starting to simulate, and we start seeing also the messages. So what we can do is through this web interface, in a very easy way, control the virtual service, but we can also see some more information. We are actually collecting the statistics of all the runs that the virtual service is actually simulating, and you can actually filter those, report, export those, and also do some zooming and manipulation with those for your kind of understanding how well you are able to simulate. And customers are also using it to calculate the ROI of the infrastructure. So if you know how much you simulated for the virtual mainframe and you compare it to the physical mainframe, you know immediately what is your ROI. We also have the audit capability. So for every action that is changing over the virtual service, we actually make a record and also some compound KPIs and metrics. So if we come back to our load testing scenario, it is already running. Another important feature is the feedback from the virtualization into the performance practitioner. So what we see here is many graphs and information about what is application doing, what is the transaction response time from end user point of view, but we want to also see that from the backend. So how much is the backend actually utilized? So your service virtualization has the integration in it, and thanks to the setup, I can go to my process shipment average response time and see this is my my response time. So not only that I see what's happening from the user point of view, I also see what's happening on a backend. If I want to answer what if scenarios and I prepare those scenarios, I can open the runtime control of the virtual service, and right from the load testing tool, I can now go and switch into the slow performance model. Remember, this is the one where we have the 1 second delay for response time. And we will see that once the test is continuing, that the results are actually picking up, and we immediately see that if this component that might be a third-party service is actually slowing down significantly, it is actually influencing the response time quite dramatically. And we see also how much is it actually simulating on the backend. Now we picked up the 1 second average response time. So you can use it also to answer the different questions. So if I have the bottleneck in my application, and I need to find the bottleneck, it's more specific, if my third-party service is actually influencing the end-user transactions, how many transactions I'm able to simulate. You can very easily just simulate and say, instead of like, you know that you are responding 700 milliseconds, let's cut the time to 500 milliseconds and see how many transactions are we able to process. And then if you find that this is a bottleneck, you can negotiate better SLAs with the provider or improve the infrastructure. So in a very easy way, we've covered 2 scenarios. One is development, how quickly I can actually mock the virtual service for my developers to work on continuously, and how can I actually answer what is scenarios in a scalable way. So if we come back to our slide, so what we've seen here is that the service virtualization is actually part of our overall suite of the testing. So we have those 3 components: designer, server, and SV management that is usually running on the backend. We have it integrated to our test automation tools, and we have it also integrated with network virtualization to mimic the parameters of the network, and it's also integrated to the quality center and ALM for a repository and a collaboration. So just to recap, so what we've seen is that for design, we have those predefined entry points, how we create those virtual services. We have coverage of many technologies. You just select the technology and start entering the parameters. And then we have a visual way to model the data and the performance. Again, focused on the data. You don't have to understand how COBOL looks like. You just focus on the data that you need to have simulated back and forth. For the scalability, we have this scalable part of the infrastructure with the web-based interface, easy to access with various statistics and metrics along the way, and giving you also the views into the structure of how much environment you have provisioned and so on. We have integrated directly to our test automation tools, performance and functional testing, so they have the same dialog to set up the conditions, and they also collect the metrics the similar way from the performance center or Roadrunner UFT actually gets the metrics that are relevant to functional testing. It's about the simulation accuracy, functional data coverage, and so on. We have it integrated to network virtualization, so for any endpoint you are able to fiddle with the network parameters in a very easy way. We have it integrated with ALM and also with Jenkins for continuous integration. So you are able to control those virtual services over the script, over the command line. Protocol coverage is expanding quarterly. We have a quite broad range of the protocols already covered, and nice pipeline of the protocols. We have a nice tool that is called Design Partnership Program, and basically customers are giving us the use cases, and we are helping them to achieve them, and then we share the technology with all of the customers that are using the service virtualization. Again, it's done quite in an agile way. So once we have it, we release the beta, and then we launch it into the product to availability of everybody. We do have a support for full automation. So for this continuous environment, you are able to have automatically included service virtualization in the tool chain, not only for the deployment. We can also control the learning process. We can update the models. You can check it into the repository, into the Git or Subversion, and so on. And for those customers that are advanced, we also offer the Extensibility and Integration SDK. We try to provide a template for the most commonly used protocols. So we, again, update it with every release, especially from those templates point of view. We make sure that the performance is actually achieved. We do our internal benchmarks, and we make sure that we are achieving the scalability. We have a capacity calculator that helps you to understand how much hardware you should have. You have to understand that the simulation is actually quite extensive and demanding on a memory and CPU, and we tell you how much memory you need if you specify how many transactions you would like to simulate. Just to give you the idea that benchmarks are actually running into thousands of transactions per second. We have two modes, one with the that is storing the data in the database as a tool where we take those data from. We have also in-memory simulation that is much faster. So just to summarize before we go into the Q&A, why you should be looking at HP Service Virtualization? So first of all, we are the only vendor with a complete lifecycle virtualization solution. We have it from user point of view, we have it from service point of view, we have it from the network point of view. We acquired Chandra, which was the leader in the network virtualization and simulations of the network, and is completely integrated in our portfolio. The other reason why you should look at us is that we are the easiest tool to use and set up the virtual environment. It's actually not coming from our statement. It was a design principle that we wanted to bring to the market, but it's actually recognized by the customers, and it's recognized also by the analysts, that the HP Service Virtualization tool is the easiest to use and set up. And you can try it. It's quite easy, as you've seen. We are also the only vendor that is certified by SAP for virtualization of SAP systems. We have an extensive and the best support of the SAP technologies. SAP itself is actually reselling the HP Service Virtualization as a SAP Service Virtualization. And I shouldn't mention the integration. Integration is actually driving the end-to-end views. We have the personas from the testing point of view that are key to our business. Those personas are testers from a functional and performance point of view. We do have also the security solutions in our other business unit, but we make sure those tools are integrated and are achieving the goals of those practitioners that they need to achieve the certain area. We also keep in mind the developers, and we are adding actually quite significant innovations for the developer personas as well. So as you've seen, we already have it, but we understand developers want to do more scripting. So we already have the scripting in the tool. You can use C# or JavaScript to express the logic in the script, but you have to understand it's difficult to maintain. But once you write it, it actually scales quite nicely. We will be adding much more innovations for the developers as well. So I should highlight that the numbers that you've seen are actually available on hp.com Go SV portal, so you can download those. It's actually quite compelling numbers, what customers are achieving with the service virtualization. You can also go into our page and download the latest release of the Service Virtualization 3.7. We offer a 3-day trial. I believe we are also the only vendor that is offering the trial to anybody to download. And also we have in a handout, we have a data sheet that you can just download and for your reference, just to recap what we've discussed. It is also available on this product portal. So with that, let's go into the Q&A.
Okay, Todd, I'm not sure if you're there, but I'm seeing one question. Can everyone hear me here?
Yep, we can hear.
Okay, I'm seeing the first question here, Marek, and it's asking us, can we say learning mode is recording real service behavior?
So learning, we don't use the recording word because it is actually not recording. What we do, we actually learn the model. We observe all the communication of the real behavior of the system, of the communication to the real system. But then we do the analysis on top of that, and we create the simulation model. So it is the best representation of the communication. And then when we simulate it, we are able to simulate it as it would be a real system. So we are trying to create a mirror of the real communication. It might be seen as a recording for a simple case where you have just stateless communication, right? It's a response and a request and a response, and it's stored in the model. But it gets much more complex when you start having scenarios, when you have a stateful conversations that depend on the order. All of it we are actually able to store in the model, and on the fly during the simulation, we are actually able to recognize which transaction is happening based on the pattern recognition, and which response we should be sending as the next one in the order. So it's not just pure recording. There is some more advanced stuff.
Thank you for the response to the question, Marek. And I'm also seeing several questions here. One other question that comes up is, do we support multi-line item in SAP for now, or we have to write extra code to make it work?
So multi-line item, I'm not sure what is multi-line item. So what we support is the standards that SAP is using. Those standards that are most commonly used are the IDOC message structure, RFC communication patterns. We also support the integration with the XIPI for various other technologies that need to communicate. But in our model, what we support is a general pattern of asynchronous communication with the multi-responses. So typically what you see, for example, in telco, is that you issue one message into the system, and then asynchronously it confirms that the message was received, and then after a certain period of the time when the phone number or other systems are provisioned, those messages start coming back as a confirmation. So we can simulate those multi-response for one request that is triggered as the actions. You can associate the timing with it as well. And in SAP, for SAP use case, we actually use this batch processing simulation, which is similar, but it's actually achieving the use case where you issue the transactions into your supply chain. And obviously, asynchronously, those orders get fulfilled, and it can happen that in a surge of the demand from the users, there's a lot of traffic coming from the partners that are fulfilling the orders, and our customers are actually make sure that the central SAP system is able to withstand those communications from the outer SAP system. It can be quite complex ecosystem. So we are able to do that as well, and it was actually co-developed with one of our SAP partners, but it's available also for other technologies. So you can use it very easily in NPU, you can use it in any asynchronous web services, similar pattern.
Thank you for the response, Marek. There are several questions related to how can we get started on SV and how can I get the rest of my organization going on this. So again, I think the easiest, shortest answer is probably to get started on the latest report that I was just alluding to in the beginning of this session, the VOC 2015 Service Virtualization Report. Feel free to download the report from hp.com, share the results of the businesses that has been adopting service virtualization, the ROIs that they experience, and this is a great way to get your management to look into this and become more aware of some of these great technology solutions that's available. And another related question to this is, how can I get started? Again, we did not have a chance to go more into this, but essentially one of the ways you can get started is to start small. Look at the projects within your groups. Find a project where you can measure the results of this and implement service virtualization to it. That's one way to do it. The other way is, if this is part of your Center of Excellence initiative coming down from your corporate, that's also a quick and easier way to get started adopting service virtualization. The third approach is what I've been alluding to earlier. One of our customers, which is not just him, but there are also other customers as well. They started trying out SV on their third-party services and components. That too is really a good way to get started because you can measure. Because every time when you access third-party components, you have to pay some service fee, time involved, and these are measurements that you can measure real quickly and easily by using SV. Now,
yeah, I would add, Tim, I would add to that try to identify where is your biggest pain, where is your biggest trouble, where is the component or system that is the most difficult to get access to, or you have the highest cost, or you need to always and ask people to do changes. Try to identify those and use the service virtualization to overcome the problem, and it starts rolling as a ball. You start seeing the benefits and how to use it in other parts of the system.
Yeah, thank you very much, Marek. That is true. And the other question, Marek, that I get here is, how many services can be run on one server node?
So it's a very good question. So I try to touch it as part of the benchmark. And so the simulation actually depends on a number of CPUs and number of memory. So we usually measure it in a transactions per second. And this is a key indicator for us, what we are able to simulate. It doesn't matter how many services are actually deployed on the server, but it depends how many transactions you want to achieve overall. So our licensing model is quite simple. We have a licensing per instance of the server in an operating system. If you put to it 4 CPUs or 32 CPUs, it's the same license. Obviously, with the 32 CPUs, you achieve much more throughput. We don't limit the number of the virtual services that can be deployed because there is no limit. The limit is how much are we able to process by simulation.
Thank you, Marek. And I know we are not going to be able to get through these questions here as we are at the top of the hour. So please feel free to continue submitting the questions, and we will get them answered and posted out later. One more thing that I would like to say before I turn this over back to our moderator is, at the end of this session, there will be a survey that will be sent out to you, inviting you to participate. Please do take a minute to help us contribute to this survey. And as a token of appreciation, there will be a gift provided to you. This is going to be a random drawing. It's going to be a Bluetooth mobile speaker with tablet stand. So again, this is a random drawing, and it's open to those in the US. And I'm going to turn this back to our moderator.
Great. Thank you very much, Kim and Marek, for this very informational webinar. I want to encourage you, just like Kim had suggested, in the handouts area, you should see the HP Service Virtualization data sheet. You can click and download on that right now. The other thing is, upcoming very soon is HP Discover 2015 in London. This is going to be from the 1st till the 3rd of December in 2015, so just a few weeks out. If you haven't had an opportunity yet, please register now. If you just click on the link that you see here, what you will be able to do is get a special early bird discount, and again, walk you right through the registration. There's also going to be a number of Vivid breakout sessions where you can learn more about HP Service Virtualization and other capabilities as well. As we look to kind of wrap everything up, just wanted to, on behalf of myself, being able to host this webinar, thanking you for attending the webinar today. Please be sure to complete this short survey that Kim had referred to after the webinar ends so that you can opt in and receive more information from HP Software. And just a reminder that the next webinar recording and slide deck will be posted to the Vivid website in the next few days, and you will receive an email to those links as well. Please find here, again, links to hp.com as well as Vivid Worldwide. And as a reminder, when you get that survey, fill it out. You'll be entered into a chance to win the Bluetooth speaker, which also has a tablet stand built in. My name is Todd DiCapua. Thank you very much for participating in this webinar today. And I'm sure you've learned a lot more about how you can revolutionize and transform your application delivery lifecycle with HP Service Virtualization. Special thanks to Vivid. Special thanks also to Kim Yeo and Mirik Novotny from HP Software. Thank you all.